Welcome to Two Projects. In this video, we are going to explain the project Deep Curve MRI, Deep Convolutional Curvelet Transform based MRI approach for early detection of Alzheimer's disease. Introduction. The project addresses the pressing need to enhance Alzheimer's disease, that is AD diagnosis accuracy, using cutting-edge imaging and artificial intelligence. With over 50 million global cases and projections soaring to 152 million by 2050, a reliable diagnostic tool is crucial. The absence of a cure emphasizes the significance of early detection, prompting the development of an innovative model named Deep Curve MRI. The global impact of AD necessitates accurate and efficient diagnosis. Early detection proves essential, offering preventive measures and delaying cognitive decline. Deep Curve MRI introduces a novel approach by incorporating curvelet transform for feature extraction in MRI images, aiming to revolutionize AD diagnosis. So, Deep Curve MRI leverages curvelet transform, as I mentioned earlier, a sophisticated feature extraction method to improve the accuracy of Alzheimer's disease stage prediction using MRI images. The model employs a shallow convolutional neural network, that is CNN, for multi-class classification, distinguishing between non-demented, very mild demented, and moderate demented stages. So, the project's outcomes cater to various stakeholders. Medical professionals benefit from enhanced diagnostic accuracy, enabling early interventions and personalized treatment plans. Patients and their families gain improved quality of life through early detection, while the healthcare system benefits from reduced costs and optimized resource allocation. Objective of the project. So, as I mentioned earlier, the primary aim of the project is to develop and implement the Deep Curve MRI model, integrating curvelet transform with CNN to enhance feature extraction from MRI images. This aims to improve the model's ability to capture intricate patterns crucial for Alzheimer's disease, that is AD diagnosis. And we aim to enable the model for multi-class classification, that is non-demented versus very mild demented versus moderate demented, and binary classification, that is non-demented versus very mild demented. This facilitates a nuanced understanding of AD progression stages, contributing to more targeted interventions. The goal also includes evaluating the performance of Deep Curve MRI against established models like VGG16, LXNet, Feed-Forward NN, and SVM. We want to assess accuracy, computational efficiency, and suitability for AD diagnosis, providing insights into the strengths and weaknesses of each approach. And the goal is to focus on early AD detection by leveraging advanced feature extraction techniques. We strive for improved accuracy compared to existing models, aiming to contribute to the development of a more efficient and cost effective diagnostic system for Alzheimer's disease. Requirements needed to execute this project are software requirements. Software needed is Anaconda. Primary language used is Python. Front-end framework used is Flask. Backend framework used is Jupyter Notebook. Database used is SQLite 3. And front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working models of flow of work. So the first step is import and required packages. So in this initial step, we import crucial Python libraries including NumPy, Pandas, sklearn, Matplotlib, and TensorFlow Keras. These packages provide the fundamental tools for data manipulation, visualization, machine learning, and deep learning necessary for subsequent stages. The second step is exploring the dataset. So, with a focus on the dataset, we delve into a multi-class MRI Alzheimer's disease dataset. Additionally, we transform it into a binary MRI AD dataset to simplify the classification task. Understanding and preparing the dataset is a crucial foundation for model training. The third step is image pre-processing. So the pre-processing phase involves using an image data generator for augmenting images, including rescaling, shear transformation, zooming, horizontal flip, and reshaping. Furthermore, Feature extraction is performed using the HOG, that is histogram of oriented gradients model, enhancing the dataset for effective model training. The next step is training and building the model. So the core of the project involves training various models such as VGG16, LXNet, feed-forward NN, CNN, that is deep curve MRI, and SVM. This step lays the groundwork for model comparison and selection based on their performance metrics. Additionally, as an extension to the project, exploration of other models like exception, dense-net, decision tree, and voting classifier is conducted to improve predictive accuracy. And as an extension again, a user-friendly frontend is developed using the Flask framework. And it includes user authentication with SQLite for sign-up and sign-in processes. After signing in, users input images which undergo pre-processing steps, and trained models are utilized for disease classification and detection. And the final outcomes are displayed through the front end, providing a seamless user experience. Now we'll understand about the algorithms used. So the first algorithm built is VGG16. So VGG16, short for Visual Geometry Group 16, a convolutional neural network architecture, gained recognition for its simplicity and effectiveness. It comprises 16 convolutional and fully connected layers. VGG16 excels in image classification tasks due to its deep architecture, enabling it to learn intricate hierarchical features. It is suitable for this project as Alzheimer's diagnosis often requires discerning subtle patterns in medical images. The next algorithm built is LXNet. So, LXNet was pivotal in popularizing deep learning. It features 8 layers, including 5 convolutional and 3 fully connected layers. LXNet employs techniques like ReLU activation, dropout, and local response normalization. Its strengths lie in image classification tasks, making it relevant for this project's focus on classifying MRI images for Alzheimer's disease. The next one is feed forward NN. So, a feed forward neural network, the simplest form of artificial neural networks, consists of input, hidden, and output layers. Information travels unidirectionally from input to output. Though not as deep as CNNs, feed forward NNs are versatile for various tasks. In this project, they serve as a baseline model for comparison with more complex architectures. The next algorithm built a CNN deep curve MRI model. So, our custom CNN architecture deep curve MRI integrates curvelet transform for feature extraction from MRI images. This model is specifically tailored for Alzheimer's diagnosis, leveraging the strengths of CNNs in image analysis while incorporating advanced feature extraction methods for improved accuracy. The next one is SVM, that is support vector machine. So SVM is a powerful supervised learning algorithm used for classification and regression tasks. It works by finding the hyperplane that best separates data into different classes. SVM is effective in high dimensional spaces, making it suitable for image classification. In this project, SVM serves as a benchmark for evaluating the performance of deep learning models. Now we'll see the comparison graphs of the algorithms built for multi-class classification. So this is the horizontal bar graph comparing accuracy scores of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. Accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. Precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. Recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis I have F1 scores and on y-axis I have algorithm names. F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for classifications. So similarly, these are the comparison graphs of the algorithms built for binary class classification. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So in these folders, I have the required dataset on which we will train the models. This is sample folder in which I have images on which we'll make the classifications. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. And this is Jupyter source file for multi-class classification, and this is a Jupyter source file for binary class classification. So these Jupyter source file contain a combination of code, graphs, and outputs all in one place. So Jupyter source file allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. Now copy the path of the code folder from the address bar of the file Explorer. I'm copying it. Open Anaconda prompt. So now use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on sign up button to register. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. Here we have to give our credentials, username and password, and click on sign in button. So it has redirected us to the classification page. So as I mentioned earlier, we can perform both binary and multi-class classification tasks in this project. So first we'll perform the binary classification task. Click on binary link. So here we have to upload any MRI image. The uploaded image should be less than 500 KB in size. Click on choose file button. So first we'll upload any non-demented stage disease MRI image. So I'm selecting this image and click on open. The image is loaded. Now click on upload button. So this is the uploaded image, and here we can see the classification, that is the patient is diagnosed as non-demented Alzheimer's disease. So the application has correctly classified the stage. Click on binary link, we'll try again. Click on choose file button. So this time we'll try uploading any demented stage disease MRI image. So I'm selecting this image and click on open. The image is loaded. Now click on upload button. This is the uploaded image, and here we can see the result, that is the patient is diagnosed as demented AD. So similarly, we can upload any MRI image and can get the classifications, the binary classifications. Now we'll perform the multi-class classification task. Click on multi-class link. So click on choose file button. So from multi folder, so these are the different types of classes I have. So we'll upload any mild demented image. Click on mild demented folder. So I'm selecting this image and click on open. The image is loaded. Now click on upload button. This is the uploaded image, and here we can see the result, that is the patient is diagnosed as mild demented AD. So the application has correctly classified the stage. Click on multi-class link. Click on choose file button. So this time we'll upload any moderate demented image. I'm selecting this image and click on open. The image is loaded. Now click on upload button. So for this image, it has classified it as diagnosed as moderate demented AD. So we can see the correct classifications here. Click on multi-class link. Click on choose file button. We'll upload any non-demented image this time. So I'm uploading this one and click on open. The image is loaded. Now click on upload button. This is the uploaded image, and here we can see the result, that the patient is diagnosed as non-demented AD. So similarly, we can upload any image and can get the classifications. Click on multi-class link. Click on choose file button. This time we'll upload any very mild demented disease MRI image. I'm selecting this image and click on open. The image is loaded. Now click on upload button. So for this uploaded image, we can see the result, that is the patient is diagnosed as very mild demented AD. Now click on sign out. So the conclusion here is the project implements diverse algorithms including VGG16, LXNet, feed-forward NN, CNN, that is deep curve MRI model, and SVM for Alzheimer's disease, that is AD diagnosis from MRI images, showcasing a comprehensive approach to model selection. As an extension, the project explores additional models such as exception, DenseNet, decision tree, and voting classifier to enrich the variety and robustness of predictive algorithms, aiming for superior accuracy in AD detection. And the incorporation of front-end development using Flask with user authentication enhances user accessibility and real-world applicability, creating a seamless interface for input, processing, and result visualization. The project addresses the critical need for accurate and early AD detection, contributing to improved quality of life for patients, optimized resource allocation in healthcare, and facilitating targeted interventions. Through rigorous evaluation, experimentation, and the development of a user friendly application, the project stands as a comprehensive and impactful contribution to the field of medical image analysis and neurodegenerative disease diagnosis.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.